Hi, we'll discuss about the Nyquist plot in detail. So the prerequisite of the Nyquist plot is the polar plot. So before starting the Nyquist plot, we'll talk about the mapping theorem. So this mapping theorem states that every point of S-plane will get mapped onto a corresponding point in G of S, H of S plane, where G of S, H of S is a function, is any function of S. That means, for example, if you are drawing some sort of a point on the S plane, definitely there will be certain point on the G of S, H of S plane. So the combination of all points in the S plane is called the Nyquist contour, and the plot of this Nyquist contour onto the G of S, H of S plane is called the Nyquist plot. So let us take an example. Let's just take the example of 0 minus 5j, and we want it to map onto the S plane. So 0 is there, and I am representing as 0 is at the origin, and minus 5j it is on the negative imaginary axis. I wanted to map onto a G of S, H of S plane where the plane is represented as S plus 2, where here S is equal to 0 minus 5j. So when I substitute 0 minus 5j, I'll get the real and imaginary part as 2 minus 5j. So we have to identify the 2 and you have to identify the minus 5j, and this origin is mapped to the 2 on the real axis and the 5j is mapped to the minus 5j on the imaginary axis. This is called mapping. So now let us recap little about our polar plot so that we will ensure that all you are understanding correctly. So let us talk about the polar plot, and I wanted to draw the polar plot on my S plane where I wanted to change the value of j from 0 to omega, and the same thing I wanted to map into the G of S, H of S plane where G of S, H of S is equal to 1 by S plus 1, where here S is equal to j omega. So when I am drawing the polar plot, I have to find out both the magnitude and the angle, right? So substituting the value of S is equal to j omega, I can find out the value of magnitude as well as the angle. That is 1 by square root of 1 plus j omega, 1 plus omega square, and minus tan inverse of omega. So by substituting the value of omega, that is starting from 0 to infinity, when omega is equal to 0, 1 by 0, 1 by 0 plus 1 it is 1, so magnitude is 1, whereas tan inverse of 0 is 0. At omega is equal to infinity, magnitude is 1 by infinity is 0 and phi is minus 90. So it is minus, so first of all we have to keep all the coordinate angles 0, minus 90, minus 1 to 70. So first of all you have to find out where omega is equal to 0 and how it is transferring, and whenever omega is equal to 0 and magnitude is equal to 1, at omega is equal to infinity, magnitude is equal to infinity. So this is how you can simply see when omega is j is 0 and how it is transferring from the polar plot, I mean from the S plane to the G of S, H of S. This is called mapping. So the left side is called contour, the right side is called the polar plot that we are representing. Now let us take the simple example like the principle of argument. This principle of argument states that, say for example, if there are poles and zeros that are enclosed, I mean encircled inside a plane, how are we going to represent is the principle of argument. The principle of argument stated that the S plane is closed contour encloses P poles and Z zeros in the right hand side of the S plane. Then the origin of G of S, H of plane is encircled P minus Z time in the anti-clockwise direction. So here what I am taking is I am taking two zeros, that is A and B, that is encircled. So now these two are encircled. Whenever there is a 0, there is a movement of anti-clockwise direction. Okay, there is a movement of the poles, that is in, sorry, when there is a zeros, there is a clockwise direction. These are all moving in a clockwise direction when there is a zeros. When there is a pole, then this will go in a anti-clockwise direction. You have to be a little careful here. Okay, so when example, let us take 2 here. In the example 2, when there are poles, poles always move in anti-clockwise direction, zeros will always move in clockwise direction. So now I am taking two poles that are encircled, and when I am trying to map onto G of S, H of 10, so these two poles are moving in anti-clockwise direction. Okay, these are moving in anti-clockwise direction, that has 1 by s minus a1. So this anti-clockwise movement you have to be encircled. That means this encircled 2 times the origin. So this is how we will represent. Okay. Now let us take an example of having both the poles and the zeros. Okay, let us take another case where there are 2 poles and 1 zeros in the S plane. When there are 2 poles and 1 zeros, then the poles are more than the zeros. Obviously, the system will move in the anti-clockwise direction. Okay, so you can simply say that whenever the number of times of anti-clockwise system, the system is said to be in unstable state. So when there are poles, this is moving anti-clockwise direction. When there are zeros, it will be moving clockwise direction. So the same thing we'll make with the help of an example in the case 3, where the system is having 2 zeros and 1 poles. You observe carefully, 2 zeros and 1 poles. 2 poles and 1 zeros. 2 poles are there. So when more poles are there, obviously this will move, the resultant of that will move in a anti-clockwise direction. So I wanted to map these two in the plane. So P of g of s h of s is equal to 1 by s minus a into s minus b. So and c is on the 0, so 1 s minus c. So when I am putting that, so obviously the poles are more, so and hence this will be moving anti-clockwise direction. So the number of times it will encircle the origin is only once. So it will encircle the origin only once. So this is how we will draw the contour. Okay. Now we'll see the number of encirclements is equal to p minus z, where p is the number of poles in the right hand side of S plane and z is the number of zeros in the right hand side of the S plane. So you can observe carefully, both are there in the right hand side. That means our intention is to find out how many poles and how many zeros that are there in the right hand side of the S plane, so that we can tell that the system is how the system is, whether it is a stable system or unstable system. The number of times it will encircle the horizon. If there are zeros, it will go in clockwise. If there are poles, it will go in anti-clockwise direction. So based on having said this, based on this, we will go for the Nyquist stability criteria. So in the Nyquist stability criteria, first of all, let us consider the open loop transfer function, that is only g of s h of s. So it is having some number of zeros and some number of poles. So that is what I am telling as k into s plus r minus z1. So there may be zeros that are there in the left hand side or right hand side. So that's why I have taken plus r minus divided by s into s plus r minus p1. So the poles that may be there in the right hand side or left hand side. Okay. Now for this I will find out the characteristic equation, that is 1 plus g of s h of s. When I am finding the 1 plus g of s h of s, the interesting facts are coming out. If you observe carefully the interesting facts, the numerator of this characteristic equation indicates the closed loop poles of a closed loop transfer function. The closed loop transfer function poles indicates the closed loop poles, and the denominator of the characteristic equation indicates the open loop poles, which is already there. Above we have seen the open loop poles is s into s plus r minus z1. So that means what is happening, whenever they give you whenever they give open loop transfer function, from there you can easily find out the system number of closed loop poles and the number of open loop poles. So based on this only, the Nyquist has proposed the number of encirclements is equal to p minus z, where here this is called p is equal to number of open loop poles in the right hand side of the S plane, and z is equal to number of closed loop poles in the right hand side of the S plane. Okay, that is most important. Z is here. This is called Nyquist criteria number 2. The earlier p minus z we have discussed is Nyquist criteria 1. This is Nyquist criteria 2. Generally people don't discuss about the Nyquist criteria 1. So I wanted to give you a complete emphasis on both criteria 1 and criteria 2. Now in order to trace the Nyquist path, we have to first of all consider the movement of the I mean, we have to completely consider the complete right hand side. That means we have to completely encircle the right hand side, so that if there are any poles that are there, zeros that are there left and right hand side, will continue. So now what I am doing, I am trying to draw a path that is starting from 0 to pi by 2 and plus pi by 2 to the minus pi by 2, having the radius is infinity. And also I don't want to encircle the origin, because as I told you, when I encircle the origin means the number of zeros or poles that are there in the right hand side. So I want to just skip that origin for time being, and I wanted to draw it. Okay, there are S1, S2 and S3. Now if you want to map the S1, to map the S1 we have to draw the polar plot. Okay, to map the S2 we have to, it is a infinite semicircle, so we have to, the having radius infinity. So that means to map the S2 we have to keep S is equal to limit r tends to infinity r into e to power of j theta, where theta is mapping from pi by 2 to minus pi by 2. To map the S3, you just inverse the S1, because inverse the polar plot. Okay, to map the S4, again the radius is tending to 0. Okay, put S is equal to limit r tends to 0, small r e to the power of j r into e to the power of j theta. So these are the, and where theta is moving from minus pi by 2 to the plus pi by 2. These are the four important points we have to be understand while we draw the Nyquist plot. So let us take an example, then we'll see. In this example, I am taking g of s, h of s as, so this is most important, right? So I am taking only the poles, that is 1 by s into 1 plus s into 1 plus 2s. Okay, so now we have to draw the s1, s2, s3 and s4. As I told you, in order to plot the s1, first of all we need to draw the polar plot. Okay, so to plot the S1 we need to draw the polar plot. So first let us the polar plot can be drawn by keeping S is equal to j omega, that you know. From that you have to find out the magnitude, and you have to find out the phase, and then you have to vary the frequency from 0 to infinity. Then you can easily do all those analysis. Now let us do that analysis step by step. Okay. So we'll let us do the analysis. This is most important while you are drawing the polar plots. Okay. Now g of j omega, h of j omega is equal to 1 by j omega into 1 plus j omega into 1 plus 2 j omega, and the magnitude is equal to 1 by omega into 1 plus omega square into 1 plus 2 omega square, where phi is equal to 1 by omega is there, that is minus 90, minus tan inverse of omega minus tan inverse of 2 omega. So now let us substitute the value of omega as 0, and when we substitute value 1 by 0 is anything 0 is infinity, minus 90 minus 0 is, because tan inverse of 0 is 0. That is the reason why it is minus 90. So when you substitute the value of omega is infinity, 1 by infinity is 0. So tan inverse of 90, infinity is minus 90. So there will become minus 90 minus 90 minus 30 is minus 270. Now you have got the values of at 0 and it is equal to infinity, and you put all those into our polar plot. 0 minus 90 minus 180 minus 270. At omega is equal to 0, it is having minus 90 having magnitude is infinity. At infinity it is having 0 at an angle of minus 270. So this is called the polar plot for the S1 that we have drawn, that is 0 at an angle of minus 270. Now in order to draw S2, so to plot S2, what we told, the radius is tending to infinity. Okay, where s is equal to r into e to the power of j theta. So substitute the value of r into e to the power of j theta, 1 plus r into e to the power of j theta, 1 plus 2 into r into e to the power of j theta. So here you have to understand carefully, the radius is very high and it is tending to infinity. So you can consider that comparatively 1, the radius is high. So I can directly take r into e to the power of j theta, I can discard 1 and 2 there. So r into e to the power of j theta into r into e to the power of j theta into r into theta. So limit r tends to infinity, r it is r cube, e to the power of j theta is r e to the power of j into 3 theta. Okay, so that is how you can substitute that So here you observe carefully. When you're trying to substitute r value is tending to infinity, this value is becoming 0. So this is the most important information. When the radius is tending to infinity, how many number of encirclements that you can see, that you can easily step out. You can easily find out from this value here. So as r is tending to infinity, 1 by infinity, it is tending to 0. So that is most important. So when the theta is varying from plus pi by 2 to the minus pi by 2, when theta is varying from plus pi by 2 to minus pi by 2, this value is becoming 0. Now we have to plot the S3. As we already told, the S3 is the inverse plot of the polar plot that we have seen, that is g of s h of s is equal to minus s here, s is equal to minus j omega. So we are just substituting j omega to be minus j omega. Earlier we have written s is equal to j omega. It is just a mirror image of that. So whenever we are trying to plot the image, you have to just keep the mirror image with respect to the real axis. This is most important. So this is most important. This mirror image is with respect to the real axis. So whenever you are trying to mirror image, you have to mirror image with respect to the real axis. Then you will get the, whenever you are keeping the value of s is equal to j omega, the complex conjugate or the reflection or the mirror will be s is equal to minus j omega. That much, that simple it is. So this is most important. Now when you are trying to draw about S4, S4 is where the radius is tending to 0. That is limit r tends to 0. So that r into e to power of j theta into 1 plus r into e to power of j theta into 1 plus 2 into r into e to power of j theta. Now here you observe the r is much less. It is tending to 0. So this is tending to 0. So you can discard the value in this. So 1 is high and 1 is high. So this will become 1 into 1 into 1. So r into e to power of j theta into 1 because that value is much less. So I am directly writing as 1 into 1. So this is limit r tends to 0, 1 by r into e to power of j theta. Or you can indirectly write as limit capital R tends to infinity. Okay, understand, capital R tends to infinity, r into e to power of minus j. I just took into numerator where capital R is equal to 1 by r. So whenever it is tending to, the radius is tending to infinity, where the theta is lying from minus pi by 2 pi by 2. Minus j theta means it is going from again pi by 2 to minus pi by 2. So this, the radius is tending to again infinity, though S4 is also, the radius is tending towards the infinity. So that means what is happening here, it is not at all going through that. So now here the number of encirclement depends upon the type of the system. If you see the type of the system is 1, the number of encirclement above the horizon is equal to 1, because you know already the type of the system. If there is a 1 by s means it is type 1, 1 by s square means it is type 2, 1 by s cube means it is type 3, 1 by s to power of 4 means type 4. Depending upon the pole location, we can tell that is the types of the system. Now based on this information that we have, let us draw the Nyquist plot. Okay, in this Nyquist plot, let us see this. So earlier that is coming here, so that is starting from minus 90 going to towards 270, and it is a mirror image with respect to the real axis, and close this path. This path, drawing of S2 and S3, this is called the Nyquist plot. And if you consider, see, it's a complete one encirclement about the horizon. So the number of poles are on the right hand side, that is equal to p minus z is equal to 1 here. So there is one pole that is lying on the right hand side of the system. Then the system is said to be unstable system. Now let us take one more example, so that will be much more clarity. When the system is having both the zeros and poles. So till now we have drawn the polar plot, which is the system is having only zeros. Now we have to draw the polar plot for the system having both poles and zeros. So while drawing the system, there are three important steps. The first step is draw the polar plot, mirror image the polar plot. The infinite number of semicircles is equal to the type of the system. If the type of system is 1, it will be once. If the type of system is 2, it will be twice. If the type of system is 3, it will be 3 times. So based on these three information, First one and second one are most easiest. The third one is only the depending upon the type of the system you have to identify. Then only you will draw this. So let us take the example as g of s h of s is 1 plus 20s divided by s into 1 plus s into 1 plus 10s. So now let us take the substituting the first of all, as we told, first of all you have to draw the polar plot. The polar plot you can draw by taking the magnitude and the phase into consideration. By keeping s is equal to j omega, the magnitude is 1 plus 20 j omega by j omega into 1 plus j omega into 1 plus 10 j omega. Phase is 1 by s is there, so minus 90 minus tan inverse of 1 j omega minus tan inverse of 10 omega plus tan inverse of 20 omega, because it is in the numerator. Now let us keep the value of and let us find out the magnitude. It is x plus I by root of x square plus y square. So first, likewise we can find out the magnitude directly, and the phase we already find out, that is minus 90 minus tan inverse of omega minus tan inverse of 10 omega plus tan inverse of 20 omega. Okay, so now what is happening here? Let us keep the value at omega is equal to 0. Okay, at omega is equal to 0. So 1 plus 0 divided by 0. So anything by 0 is infinity. So magnitude at 0 will become infinity, that we have to write. And minus 90 minus tan inverse of 0. So our tan inverse of 0 will become 0. So at omega is equal to 0, that is again equal to 0. But important point is that there is a 0 here. Whenever there is a 0, it is according to our polar plot, we are already told that it should cut the negative real axis. That means the phase should be equal to minus 180 degrees. So minus 180 degrees is minus 90 minus tan inverse of omega minus tan inverse of 2 omega plus tan inverse of 20 omega. So minus 180 minus 90 will become minus 90. So minus 90 plus tan inverse of 20 omega is equal to tan inverse of omega plus tan inverse of 10 omega. It is in the form of tan inverse of a into tan inverse of b plus. So there will be a plus b by 1 minus ab. So the tan inverse of formula. Okay, that is simple as that. So now I am doing the same thing here. So that 90 I am taking it to here. So by substituting the value of tan inverse of 20 omega is equal to tan inverse of omega plus tan inverse of 10 omega. So there is already there is a 90. That 90 we have to add here. You should not forget about that. Okay, that 90 is there. You should not forget about that 90. So 20 omega is equal to omega. So a plus b, that is 90 plus tan inverse of 20 omega is equal to tan inverse of omega plus 10 omega, that is 11 omega by 1 minus 10 omega square. Now consider the take on both sides. The tan of 90 plus theta cot of 20 omega is minus 1 by 20 omega. So by substituting the value, 11 omega by 1 minus 10 omega square is equal to minus 1 by 20 omega. You will find out that omega value is always in the imaginary axis, so it is not cutting at all anything on the real axis. So we are happy. No, there is no issues. Okay, so we can draw the plot easily. So this is one type of special case. Okay, here it is always imaginary. That one we have concluded. So now substituting the value of omega here, when omega is equal to 0, so the magnitude is infinity and the phase is minus 90. Okay, phase is minus 90 and omega is equal to infinity, so the magnitude is equal to 0 and the phase is minus 180. So this is minus 90. So at omega it is infinity minus 90 and at infinity 0 and minus 180. So that is how we can get all those values. Now let us draw the simple plot. So that is most important here. It is not at all cutting any negative real axis, so it has to discard then and there itself. Okay, it is not cutting any negative real axis. So let us draw the plot here. This plot, Nyquist plot, you can draw here. So here in Nyquist plot you can see that, so when it is at infinity, it is touching infinity and it is going to minus 90. So the mirror image is infinity, minus 90, 0, minus 180, mirror image of that, and close that. So here the type of the system is also 1. So we will simply say that the it is encircled by only once.